Hello, welcome to a new video series. I'm very excited about this video series because I am going to show you how to write some code. I always show you how to write code. Well, I don't always, but typically I show you how to write code and then I run the code on this computer here. And what I'm going to show you is how to write code here and have it run somewhere else. And this can be very useful for a lot of reasons. One of the main reasons, or these days you might want to do that, is to run your code on a more powerful computer that can do some kind of machine learning task that might take all night, and you can just be playing your whatever other video game and checking your email while that's going and get the results when it's done. And I'm going to show you how to do this with a particular platform called Spell. And this video is sponsored by Spell. So I'm going to do a couple things. I'm going to talk about what is Spell. I'm going to show you how to use it. And I'm going to run a simple example with just one little Python script that I make on this computer, run it over there, and see the results. Then, look in this video's description. There will be links to 2 upcoming live streams with 2 guests. First, Nabil Hussain is going to come and show you how to train an LSTM, long short-term memory network. It's a special kind of neural network model that's useful for working with sequences, and in particular, you could generate text as a sequence of characters with it. So we're going to look at how to train an LSTM model using spell.run, and then have that model that you've trained work with, say, the ML5 TensorFlow.js library. ML5 or TensorFlow.js library. Then Yining Shi, who has previously appeared on the coding train in the Brick Breaker tutorial, she's going to come and show you some stuff about working with images. Maybe we'll do style transfer, maybe we'll do pix-to-pix, maybe both. And so she'll come and show you how to train a model for those concepts and execute that on Spell, and then also work with that with the ML5.js library. So you can check the video's description for the times of both of those live streams. You can tune in live and ask your questions, or simply watch, if the live streams have already happened and you're watching this video, just click the link and you'll be able to watch it right there. Okay, wonderful. All right, so first, let's talk about what is Spell? So I've talked about the idea of client-side programming and server-side programming, and this is sort of a similar thing in the sense that we do have a client computer, my laptop, which is like the coding train. Then there is this service, which is called Spell. If I could spell Spell, that would be good, which has lots and lots of computers sitting there somewhere in the cloud. They have computers with different CPUs and GPUs, and I'll kind of get to that as we go through all this material. So typically, if I'm talking about client-server, I might be saying you program your website, then you upload your website to some server, and then other people can access your website. This is different. What we're talking about is allowing these computers to act as a cloud computing resource, essentially, that you could write a script. So maybe you have this Python script. You set up your entire Python environment on your computer. The Python script works with it, and you could just say, with typing in just an instruction, spell run myscript.py. It will get sent to a particular server, one that you've requested, the kind of server you're requesting. You're not requesting a specific computer, you're requesting the kind of computer. I want this GPU, and that means GPU, by the way, means graphics processing unit, and that typically is a powerful processor that's really useful with machine learning models. So you're going to request a particular kind of computer, it's going to run it, it might finish, it might generate some files, like maybe it's going to say, hey, here's your poem, or here's your image. And then you can request to ask for the results back. And if that task takes hours or even days, which is not crazy at all in the world of running machine learning models, you can send it, close your computer, check, go to the library, get on the computer there, go to the Spell website, see what the progress is, go to sleep, wake up, check the progress, probably get a notification. All sorts of things are possible when it's done. So this is exactly what I want to show you. And in case you're following along, this is my kind of mental list of all the pieces, a little outline of what I'm showing you. So really all I've done so far is talking about what is Spell. The next thing I want to do is install Spell. Okay, so the first thing that I want to do is just go right to the spell.run website. I'll link to it in this video's description, but it's pretty easy to type it in right to your browser. The next thing you're going to want to do is click sign up and sign up for an account with your email address, name and email. I already have done that, so I'm just going to log in. You pause this video and sign up for an account if you want to follow along. And then I'm now logged in, and you'll notice I'm getting this message. Spell is offering a $100 GPU credit, meaning you can use their GPU machines for free up to what would normally cost $100. You'll have to enter a credit card on the billing page to unlock that feature, and afterwards there's a charge per hour using the resources. I will note that they have a good notification system set up, so you can set it up to warn you whenever you're down to this much, so you should never see any unexpected charges on your card. Okay, so once you're signed up, the first thing you want to do is type this, pip install spell. That easy. Now, where do you type that? So one thing I should mention is there are a couple prerequisites for this, following along this tutorial. One is you're going to need to have a Python environment. Most computers kind of come with Python installed, or you can install it, and I'll link to a few resources for installing Python. I'm using a particular tool in this video called Virtual ENV, Virtual Environment, that lets me create a Python environment that I can kind of like turn on and turn off. It's useful. You're also going to need to know something about Git, how Git works in order to work with Spell. And I will also link, I have a video tutorial series about Git and GitHub as well, which I will link to, but those are prerequisites. Once you have a Python environment set up, you should be able to go to any terminal console application that you're using and type in pip, Python package something or other, install Spell. So I'm using iTerm, and you can see that I'm on the desktop, and this spell-demo, this is a message that's showing to me that's part of virtual environment. So I have my spell.demo virtual environment set up, and so I can just write pip install spell, and then I can wait. Oh, that was so fast, and it is installed. And I know it's installed because now if I type spell, we can see that something is happening. Normally, if I would just type spell into the console, into the terminal, it would say, I don't know what that is. Okay, the next thing I want to do is actually log in. So what I've done, actually, let me say something. What I've done is I've installed, I just have to come over here just to write this down, a command line interface. So how do you control Spell? There are two ways to control Spell. One is through their web browser interface, which I will show you at some point. Another is through a command line interface, meaning you can type in commands on the command line on your computer to interface with Spell and control it. So and every command is going to start with Spell. And now I'm going to say spell login, and I'm going to put in my username, and I'm going to put in my password, silly unicorn. And there it is. It says, hello, Dan Schiff. So I know that I'm logged in now. And I can also do things like say, spell who am I, just to check like, who did I log in as? And you can see, okay, there's my username. You can all email me now at daniel@thecodingtrain.com. And you can see when my account was created, June 1st, 2001. And my last login was 10 seconds ago, because I log in a lot apparently. All right, so we have spell working. This is actually pretty easy. Now I can do stuff. So I could type spell, anything that I can run on the command line. For example, I could type echo choo-choo, and echo is a command for the computer to echo back to me whatever I type after echo. So now if I want this command, echo choo-choo, to not run on my computer, but to run on spell, all I have to do is say spell run echo choo-choo, and here we go. Now it's going to take longer. Oh, whoa. Oh, so first of all, this is very important. I'm very glad that this happened because I meant to mention this. Spell, as I was saying, you need to know something about Git, which is version control software. Spell is designed to work best when you run commands from within a directory that is a Git repository. At the moment, I don't need to worry about that. I'm just trying to say choo-choo. So I'm just going to say continue anyway, and then of course in a moment I'm going to run the commands from a Git repository. So you can see he's casting spell number 9. This is the 9th time I've ever tried to run something on spell. A machine requested, it's done, it's building, it ran, it said choo-choo, it's saving, pushing, total runtime 5 seconds, complete. So here's the thing. This took almost 6 seconds to run, whereas if I just did this, it happens in milliseconds. There is overhead in communicating with the server, requesting a machine, sending the command, running the command, getting the message back. But all that overhead is totally worth it when you have to run something that you need a powerful GPU that doesn't exist on your laptop, or that just is going to take, it doesn't matter if you're adding 5 seconds if it's going to take 5 hours. So next step, let's actually have it run some code. So I have already, I'm in a directory called coding train spell demo, and this is code band.py as a Python script. I actually wrote a Python script, sort of. This is borrowed from a tutorial from Allison Parrish, and I will link to that in the video's description. But what this does is it loads a JSON file, and this is important because I want to show you something about loading data. It loads a JSON file with some data in it, it picks some random stuff out, and then it spits that stuff back out to a text file. So for example, if I just were to say Python band.py, this is me running the Python script on this laptop, what it does is it picks a set of random instruments and shows them to you. Let me run them to you again. It picks 10 random instruments, and there you go. It's my random band, the randoms. And it's also in a file called the band.txt. It wrote it out to a file. So this, while I'm not suggesting that this particular code is anything interesting, this shows you the machine learning process. If you're going to use this for machine learning, you don't have to, you can run any code on Spell, and there might be other things, but the thing that I'm going to show you with that we're going to show you in future live streams with guests, LSTM, style transfer, the idea is that you're going to load in some data, crunch the numbers for a very long time, and then spit out a result. And that's exactly what this is doing. Loading a JSON file, running a sort of an algorithm, and writing out a text file. So maybe that output's going to be a model file or an image or something else, but all the same stuff will apply. It's time to run band.py now on Spell, not locally. So I'm going to ask the Spell server to run that Python script. So all I have to do is type spell run, and then the same exact command that I would have typed anyway. Python band.py. Now here's the thing. This is going to work very fluidly because I am in a directory that happens to be a Git repository. Spell knows how to transfer files back and forth using Git, how to look at your last commit message and have that be something that's noted. At what time did you run this? So all of that, if you have your script inside of a Git repository, things are going to work really nicely. So and you can see that I have my terminal configured in such a way to show me information about what branch I'm on and in my Git repository. And I have a separate video that kind of shows how I'm doing that, which I'll link to in the video's description. Okay, so ready? I'm going to press enter and run this. Okay, so here we are. It's casting spell number 11. It was spell number 9 before because I did something that I made a mistake with number 10. That's not, it got edited out. Okay, so you can see it's building it, it's running it, it's done, it's printed out the output, saving, done, and run number 11 is complete. Now that it's finished, I want to be able to look at the results. I want to see the results of whatever algorithm I ran. I can see it here because I had it kind of console log it, but I want that file. That file is not on my computer. Remember, I ran the code on Spell's computers, so I need to get that file. And there's two different ways you can do it. So one way you can do it is actually just by going to the browser. So here I am logged into Spell. I'm going to go here and click Runs. There's also this idea of workspaces, but Runs is where I can see all the different things that I've done recently, and I want to find run number 11. So I'm going to click on Runs, and I'm going to click on run number 11 here. And here we can see, look, this is actually what ran, spell run. Now, I didn't type this in. I didn't request a CPU machine. The default is the basic CPU machine, meaning no special fancy graphics processing unit. And this is actually free. So the basic computer, it's not going to do anything much better than I could do already on my laptop, but that is free. And then you can see python band.py. There's information, the sort of log of what happened is here. And then right here, look at this. The band.txt, that was the output. And I can just click download. And there it is. I've already done this in practice, and you can see there it is. That's the results. So in a way, we're done. Like, I'm going to show you more things, but this is the basic idea of Spell. I wrote some code. I have an environment configured on my computer. I don't want to have to do, I want to run it somewhere else, but I don't want to have to do a lot of work setting up another environment. Spell is going to be able to duplicate your environment and run your code very easily by using Git and other things that it knows how to integrate with. So this is really wonderful that I have this like web interface and I can see what happened. I can click through my runs. I can see band.txt. I can just download it really easily. But most of the time, you're going to want to just continue all of your workflow through that command line interface. And in fact, you can download the file and do a lot of other things from the command line interface. I'm going to show you a couple more commands, and then I'm also going to show you where you find all the documentation for all those commands, because I actually don't have these things memorized. You shouldn't have them either memorized. It's all about looking up and reading through the documentation. Okay, so let me go back to the terminal. So one thing I'll emphasize, I'm just in the desktop now. I don't have to be in my project folder to interface with spell. If I'm running the code, I want to be in the project folder. But if I just want a file, I can say something like spell cp for copy runs, and then I need to specify which run. Now the number of the run is the most important thing, /11. It was run number 11, I remember that. And so it's going to say copied one file. I can actually go to the desktop now, and we should see that there it is. There's this file, the band.txt, and there, once again, is the band that came out of that particular run. Let's just really quickly do this again to see how everything changes. I'm gonna run it one more time. Okay. Run number 12 completed. You can see it's a different band, fiddle to all the way to oboe. So I can just go back to desktop and say, hey, give me now the file from run 12. And then I can just go to the desktop and we can say, right, fiddle down to oboe. The new file has come in and replaced it. You know, it's up to me to manage my file system if I want to like rename the other one and keep that one, that sort of thing. But all of this has been saved. I can just go quickly back and grab the file from number 11 now if I want. It's all there on the spell server for you. So the next thing I want to show you, which is pretty typical of working with a machine learning algorithm, is that your data might be a big set of images or a lot of text files. That's not going to be something that's part of your Git repo. Your code and your algorithm is all there, but the actual data is something that you want to treat separately. And this is where you want to use two important commands. Right? So before I just had my instruments.json file right there in the repo so my Python code could pull it up. But if I want to just have my code running on spell but try with different data files, I'm going to need to upload the file. So I'm going to use spell upload. And then what I want to make sure is that that's uploading it to spell, but there's another concept here of mounting. So if I have a whole set of uploads, I want to mount a particular one, meaning I want it to be available for this particular run. So let's look at how that works. So I've modified, to show you how that works, I've modified the code to have it just pull from any text file. So when I run, when I now say python band.py, I have to give it a data file. So I can say data.json. And data.json is not part of my Git repository. It's just a data file. So what I want to do first is actually say spell upload data.json. Enter a name for the upload. So actually it's important that I reference a name because I want to like organize my stuff in a way that I can remember later. So now it's going to tell me, let's call it, let's just call it a demo. You know, maybe I want to call it, actually let me call it like JSON, JSON bands, like band, I could call it bands, or instruments. Let's call it instruments. So, okay, so now you can see it's uploading it to uploading instruments. Let's go to the spell website. And when I look at the website, I can now go to resources. And we're going to see here, look at this, under uploads, instruments, there's my resource, data.json. So now I need to make sure this resource is available, right? Like, is it available just by default? I can say, now I can say spell run python band.py data.json. And it's going to run it, casting spell number 14. Building machine, running. It couldn't find that file. See, it is through an error. Open file name. It couldn't find this file that I want, data.json. To add that file for it to be available as part of the run, it needs to be mounted. And this can be done actually by just modifying with an argument the spell run command. So in other words, I want to say spell run, and I should have been putting the command in quotes because it's going to like keep it together as a unit. So I can say python band.py data.json and then -m, and now the path to that. And the path to that is what? Uploads. What did I call it? Instruments, I think. instruments data.json. So if I had a bunch of different instruments files, I could run it just by picking the one that I want to mount for this particular run. So let's give this a try. And this is a very common thing. This -m, there's lots of other dash this, dash that, dash this, so that I can modify it. I can request a GPU, or I can ask it to do this. So I'll look at that when I show you the documentation. OK, let's give it a try. Oh, we're number 15. This is so exciting. Machine requested, mounting, run is running. There we go. So we can see it worked. Now it used that file. Oh, that's wonderful. Well, I'm kind of finished. I mean, there's so much more. And as I said, there's going to be 2 upcoming live streams showing practical machine learning examples that you can stay tuned for or watch if you're watching this sometime in the future when those have already happened. But I do want to mention a couple other things. So let's run this on a GPU. Why not? Let's make use of a powerful GPU. I've got $100 in credit. So let's go here and see. How do you find out all the things you can do? So the main thing you want to go to is here under documentation. So I'm going to click documentation. There's a quick start guide. Essentially, the quick start guide is what is in this video in a more succinct fashion. There's some core concepts. There's guides for particular examples like style transfer already, translating text, recognizing numbers. So I encourage you to look at those. But what I'm really concerned with right now is this command line interface documentation. That's what I really want to look at. So I'm going to go there, and you can see this is all the stuff that I've been showing you. Spell who am I, spell upload, spell stop, spell PS. This is a really useful one. So spell PS, display all user runs and their details. Because one thing, by the way, you should note, if you might sort of think like, oh, I'm going to just run this, and then like, oh no, I didn't mean to do that. Let me quickly hit Control-C. Well, guess what I just did? I stopped viewing logs with Control-C. That didn't actually stop the process. If I want to stop the process, I've got to actually use, probably spell.stop. And spell.stop, I can stop a particular run ID if it's like taking forever and has a mistake in it. That one probably already finished because I was talking, but I could say spell-ps. Oh, sorry, just spell PS, no dash. And now this is everything I've ever done, basically. This is, you can see back, like when I first was doing something, I was running some tests, spell tests. It's always telling me the machine type, what the thing was. This is a little bit awkward to look at because it'll look really nice on your computer, especially when you have like a smaller font and like it's all nice. It'll look something nice like this. But I have like a big font so you can see it, and I don't know, I'm like, my computer has gone crazy. But this is the kind of thing that you want to look at and do. So the one thing that you're going to want to really see is I'm looking for, spell.run, and now the arguments for it. So we can see that -m was for mounting. And then also, this is really important, --pip. This is if a certain dependency. My project was just like a simple one, so it didn't really need any dependency. But this is important so that when Spell runs it, it uses the same Python packages that you're running. And by the way, Spell also supports other environments. I'm using Python because the future examples and a lot of machine learning examples run through Python, but you know me, I don't really know Python, and maybe I'll come back and show you a JavaScript thing with Node. All these other environments are supported on Spell as well, but here's the important one, -- machine type or -t, and you can see these are the different machine types. Probably the further you get to the right is kind of the bigger the one, and you're going to want to look through the Spell website for more documentation on each one of these. But let's just pick one for fun. Let's try a V100. I feel like that's kind of like a reasonable GPU that's not too crazy. To run it on the GPU, I'm going to do exactly what I did before. Spell run python ban.py data.json -m, an argument for mounting that data.json file, and then also I need another argument, -t. -t is for -- machine is to select the machine. I'm going to pick V100, which is a machine that has a GPU that I'm excited to try. And now I'm going to hit enter, and we're going to run it on the GPU. Okay, let's go. Okay, so here's the thing. I am running this code now on a machine that has a powerful GPU, but I'm not actually making use of any of the code libraries that would actually make use of the GPU. So technically, this is really going to be the same thing, and it already finished. But when we get to the next tutorials that are going to come in the future, looking at LSTMs and style transfer, pix-to-pix, those will really make use of a machine with a CPU. Okay, it finished. It took 7 seconds. There we go. All right, so that's going to wrap things up. I hope that you enjoyed this tutorial. I hope you learned a little bit about what it means to use a cloud computing resource to run code that you're writing on this computer somewhere else. You can do it in Python and in other environments as well that are supported by Spell. Thank you so much to Spell for the opportunity to do these tutorials. I really appreciate it. I've had a lot of fun playing around with the platform and hope to use it again in future projects. So go over to the website, spell.run, give it a try, ask your questions in the comments, look in the video's description for 2 links to the upcoming live streams, or if those have already happened, those links will be replaced with the archive of those live streams as well. So I can't wait to see what you make, how it works for you, what kind of things I forgot to talk about that I get to answer in the comments, and I'll see you again someday on The Coding Trade. Choo-choo!